Okay, so this lesson is going to be on differentiating exponential and natural log functions. So if we start by remembering what we mean by an exponential function, the exponential function, the general function, if we have done as a graph, that is the graph of y equals a to the power of x. So if that is the graph of an exponential function, y equals a to the power of x, what we're looking to find is the gradient of this function. And there's a special value for this a here, which when you then do the gradient function looks exactly the same as this graph. So the gradient function, when you do it, you get exactly this same graph again. And that value of a, when this happens, is a number that we've encountered before. It's e, which is the number, if you remember, 2.71828, and so on. So what we're saying is, what happens is, that e is a special number, because if we start with y equals e to the power of x, and we differentiate that, it stays as e to the power of x. It doesn't change it at all. Okay, the other rule we need to look at is if we have a graph of y equals log x, a natural log of x, and if we differentiate that, something a bit different happens. If we differentiate that, we end up getting 1 over x as our function. So let's just have a quick look at an example of one of these and then see how we do it. So for our example, if we have y equals 2e to the x plus 3 log x plus 4x, and I wanted to differentiate that. So if I were to differentiate this, y becomes dy by dx, and 2e to the x, well, e to the x doesn't change when we differentiate, that stays as e to the x, plus this log x here, log x, will change to 1 over x. So if it's 3 times 1 over x, that would become 3 over x. And the 4x, when we differentiate it, becomes 4. Just one more point before you go on to try some questions. I know this confuses some people. Just remember that if you have e to the power of log x, that is just equal to x. E to the power of something and log are inverses, so technically they cancel each other out. So if in a question you come up to a point where you get something like that, then the answer is simply 4. Once you've had a check through that and made some notes, can you, in your textbook, go to page 371. It's exercise 12F. And can you have a look just at questions 1 to 6? For example,